Hi, I am Dr. K. Prakash, Assistant Professor in CSC Department. Today I will present a lecture on motivation for sampling and samples for training RBMs in deep learning. The main aim of this particular lecture is to familiarize the students with the concepts of sampling and different types of sampling techniques for training RBMs. And coming to the objectives, to introduce the concepts of sampling and various types of sampling techniques for training RBMs. And at the end of this lecture, students will be able to understand the concept of sampling and the sampling techniques such as Gibbs sampling, contrastive divergence sampling for training RBMs. And this is the outline of today's lecture. Motivation for sampling. Gibbs sampling for training RBMs, contrastive divergence for sampling for training RBMs, and summary of the lecture. Motivation for sampling. What is sampling? In general, sampling refers to subset of a data. So what is the necessity of selecting a subset of data? Whenever we are trying to whenever you are trying to input the population or input all the data to a machine learning process, automatically it will slow down the process. So and also while dealing with big data, it is very difficult to deal with such a huge volume of data. So it is very essential to perform sampling on the data, and it is a common technique applied in machine learning and deep learning, where we perform training, testing and validation of the data. And this is the sample representation of data here. This is the population, and these are the samples identified from the population. These are the various techniques. Here, based on the requirement, the respective technique can be applied. These are the key motivations for sampling in the deep learning: efficiency in the training, data augmentation, imbalanced data sets, bootstrapping, and exploration and uncertainty estimation. We will discuss one by one in the forthcoming slide. Coming to the efficiency in training, sampling allows to work with smaller and manageable subsets of the data, and it makes the training faster and more practical while machine learning process is going on. Data augmentation. Here the augmented samples help the model to generalize and make the model more robust during the machine learning process. Coming to the imbalanced data sets. Here the sampling techniques can be applied to balance the data distribution. Motivation for sampling. Coming to the bootstrapping, here bootstrap samples can be used to train multiple models, leading to better performance and model robustness. And coming to exploration and uncertainty estimation, here it enables to explore action spaces and estimate uncertainty in the data. Training of restricted Boltzmann machine, which is also referred to as RBMs. Here there are two types of training steps: Gibbs sampling and contrastive divergence sampling step. Here these two techniques are useful for finding the samples to train the RBMs. Coming to the Gibbs sampling, here this is the RBM structure, where there is a visible layer and hidden layer. Here we will focus on these two layers while performing the sampling in the RBMs. Coming to the initialization, here there are several steps in the Gibbs sampling. Coming to the initialization, start with an initial configuration of the visible and hidden units. And Gibbs sampling steps, the major steps are update hidden units, update visible units. Here coming to the update hidden units, whenever we are given with visible units, we need to find out the hidden units. Similarly, whenever the visible units are available, need to calculate the visible units. So these two steps are repeated until we find the sampling. Once the sampling is available, that can be applied on various tasks such as generative modeling, feature learning or inference. Coming to the contrastive divergence sampling for training RBMs, here contrastive divergence is a popular training algorithm. It is a form of Gibbs sampling where we can estimate the gradient of the likelihood of data. So the key idea is to estimate positive and negative phases. So here the contrastive divergence K represents K is the number of Gibbs sampling steps. It is a most widely used variant of the algorithm. And coming to the steps involved in the contrastive divergence: initialization, positive phase, negative phase, update parameters, and choice of repeat the steps, choice of k and CDK, and these are the steps. Coming to the initialization, first initialize RBM parameters such as weights and biases. All these weights and biases are randomly initialized. So coming to the positive phase, here in this phase we will compute the activations of the hidden units. Sample hidden units states from their conditional distribution using the activations. So computing the positive gradient term is the most important task. Similarly, and coming to the negative phase, here in this particular the model has reached a particular state such as fantasy sample. So computing the negative gradient term, which is a outer product of the visible and hidden unit activations from this fantasy sample. So updating the parameters. So the main purpose of updating the parameters is to minimize the difference between positive and negative gradient terms, and these steps are repeated until the suitable sample is available for the RBM. So the choice of k can be user defined here, either we can use 1 or 2. So whenever we increase the k value, automatically it will lead to some other issues such as overfitting, etc. And coming to the summary, restricted Bayesian machines are probabilistic graphical models. They are mainly used in machine learning for unsupervised learning tasks. Sampling methods like Gibbs sampling and contrastive divergence samplings are mainly for approximating the likelihood gradients and updating the model parameters in the data. These are the books. You can refer these books for understanding RBM's concept. These are the web links. These are the self-assessment questions. These are the terminal questions that you can refer for sampling techniques and sampling RBMs. Thank you.